This is Camille Fairborn from Utah State University, and I'd like to welcome you to today's Cause Teaching and Learning webinar. We're pleased to have as our presenters today Dr. Lynne Stokes, who is a professor and chair of the Department of Statistical Science at Southern Methodist University, and Dr. Monnie McGee, an associate professor in the Statistical Science Department, and also Dr. Pavel Nadolsky, who is an associate professor in the Department of Physics, also at SMU. For today's webinar, they will give a presentation entitled Flipping the Classroom with Just-in-Time Teaching. The way the webinars work is that all listeners are muted during the webinar. You can ask questions at any time by typing them into the questions box. We'll be sure to ask those questions towards the end and give the presenters a chance to respond. You can also use the chat box if you are having any technical questions at any time during the webinar. At this point, I'll turn things over to Dr. McGee. Monnie, go ahead.
All right, thank you very much, Camille, and thank all of you for attending and taking time out of your schedules that I know is probably what's the beginning of semester for most of you. So as we go through this webinar, I would like to talk a little bit about student mastery, which is what we all want from our teaching and from our classes, and then notions of flipping the classroom, and we'll go through the analysis of the sample just-in-time teaching assignment that you were asked to do when you received your welcome message and the links for the webinar. If you haven't done it, don't worry about it. We're just trying to illustrate how this might work in a real classroom setting. We're also going to do a little bit of some things that we do in class that are not that are more active, like Thinkpairshare. Some of you may have heard of that, and I'll illustrate that as well. Talk a little bit about the week in the life of a professor that is doing just-in-time teaching, and some things that we've learned along the way, the best and worst practices that we have learned as we've been doing this, and some assessment that we have tried to do or we have done in order to elicit whether or not students are actually doing better with this type of method than with the standard lecture and homework method. And then give you some ideas of some baby steps. How can you start doing this? If you're not ready to go full throttle, that's fine, but and it's probably not wise to do that. But how you can start doing this, or just some ideas for doing that. And you may have some of your own, and that's fine. Okay, so one of the questions that is asked on our student evaluations at SMU is about how many hours per week students spend studying in a course outside of the class time. And we know that students, and typically for a 3-hour class, that means you're supposed to spend 3 hours outside of class studying for every 1 hour that you're in class. So ideally, students would be spending about 9 hours a week studying, and sometimes even more if there's an exam or a paper or something like that due. The thing is, most students don't do that. The most common answer is number 1 there. 0 to 3 hours. They're expecting that they get all the material that they need in the lecture and they do their homework, so that's their outside time. But as you may remember from a book by Malcolm Gladwell, that it takes about 10,000 hours to achieve mastery of anything. And maybe we don't want students to master statistics at the PhD level, but we certainly do want them to have enough knowledge where at least they know where their knowledge ends and they know when they can get help. So maybe mastery is not completely the right word, but at least a level of literacy, in a sense, of after taking an introductory statistics course. And we know that less than 3 hours a week is not enough to achieve that. So the purpose of flipping the classroom, or the idea behind flipping the classroom, is to increase the time the students spend with the material. And the idea is that the material that's done in class, usually done in class, like lectures, for example, is done outside of class. So what typically happens is there's either a video or a reading assignment or some other sort of activity that the students are asked to do outside of class. And these are typically things that most, or the classical style, I suppose, of professor would do in class. They would do a lecture in class and homework outside of class. Flipping the classroom turns that on its head and said we're going to do the lectures outside of class using video or reading, and then we're going to do homework, in a sense, in class. So that when the professor is there to help students with their misconceptions or help students when they get stuck. Now, there's a continuum of possibilities on this. You do not have to go all the way. All my lectures are going to be out of class and all the homework is going to be done in class. I've seen professors do it that way and it's worked fine for them. But in general, what we wind up with is some sort of mix of these things. So we have some material that's presented outside of class, facilitated by something like a web, a learning management system like Blackboard, or we use Canvas at SMU and Moodle. I know there are many others. Or there's some reading that's assigned. Also, we do, and the material that's done in class can be in the form of activities. It can be in the form of really quick assignments, group work, those sorts of things. It can also start their homework assignments. I've actually done that in class before to say, okay, we're just going to start the homework assignment. And if you have any questions, please let me know. And that works really well in the case where you have computer code, for example, that students need to know how to do. So there's not just one way of doing this, and that's my point when I mentioned that there's a continuum of possibilities. The goal, again, is to increase the time the students spend with the material, and I think any incremental progress you can make in that direction will help the students learn the material better. So here's a link to the sample JIT assignment. I'm saying to do it now, but actually what I'm going to do is just kind of fly over this. So if you can't actually click the link on your screen, then just don't worry about it. It should have been sent to you in the email that was that you got when you registered for the webinar. Again, don't worry about it right now. We're just trying to mimic what students would do. So what would we do? We would send some sort, we would have some sort of assignment posted on the internet, on the learning management system, Canvas, for example, before class, and we would tell students that this is going to be due a certain amount of time before class. So, and that's pretty much up to the professor. So if you have an 8 o'clock class in the morning, you might say that the assignment's due at 8 o'clock the previous night. So that gives you time to look at their answers and put together what the students are understanding, what the students are not understanding, and put some assignments together to help them understand better or just to practice the material more, and then you can go to bed. Now, so it kind of depends on when you have the assignment. Now, I've had classes at 12:30 in the afternoon before, and their questions were due at 11, and that gave me an hour and a half to go through the questions, check some really quickly to see if there were any major issues that I needed to correct in class, and try to put together some assignments. I don't know, an hour and a half may be too short of a time, but anyway, that's it's a few hours usually before class, or maybe 12 hours depending on when your class is. So that's the idea of the sample assignment. So the JIT part here is just-in-time teaching. So the just-in-time part is this idea of students are answering questions on material that they should have read or viewed, and your just-in-time piece is that you are correcting any misconceptions as they form in the student's head. So you do not want a student to carry a misconception or a wrong idea or a wrong method of calculating all the way through to an exam where it can really hurt them. You want to catch it before there's a high stakes sort of assignment. And speaking of stakes, by the way, I know some of you might have questions about grading these. Typically what I do in my classes, and I think Lynne has done as well, is to do these JIT assignments are 10% of the grade, sometimes 15%, depending on the class. They're never more than 15%, and the reason is I want students to do them, so I don't want them to blow them off, so they can't get an A in the class unless they do them. But at the same time, I don't want it to be a large percentage because sometimes you forget and you miss and that sort of thing. In addition, when I say graded, they're not graded for correctness necessarily. They're graded for how well the student expresses their reasoning. So if you have a question that is pretty tricky, like we did on the sample JIT assignment, we'll get to that in a few minutes, the point is not to get the answer right. The point is to understand how the students are thinking through it. So it's always a good idea to have the question and then some sort of explanation of their answer, because that's where the students' thoughts form, and we want to get at how the students are thinking about the material and where their thinking might have gone off on a tangent or gone off in a wrong direction. Or maybe they're going down a really great direction that you didn't even think of. And that's really cool when that happens as well. Okay, so the first question was this one, and you've probably seen this question before in introductory statistics courses. You're flipping a fair coin, H is heads, T is tails, and you ask the students which one is the most likely to occur. Of course, those of you who answered this question, so this is actually what I would do in class. I would show the question, I would show the answers, and then I would tell them the correct answer. Well, the correct answer is equally likely. And then I would go back and show some of the student responses. Now, in this case, everybody got this right in this particular group, and that might be the case in a real classroom as well. I would say, okay, everyone got this right. But a lot of times I've used this one in class a lot, and sometimes I use it at the beginning of the semester, and then it shows up again on the final. So I want to see if the questions that the students or if the students have changed their thinking about randomness. But most of the time, about half the time, students will answer B. So let me flip back to what B is. This one where it sort of looks random, and that's their reasoning. It looks the most random. And then, of course, when we talk about probability and independence and multiplying probabilities, if they are independent, then the students get that these sequences are equally likely, usually. I rarely have anyone that answers this question B on the final. And of course, you can talk about with the students, if just because it looks random doesn't mean it's necessarily more random than another type of sequence. So there are many things you can talk about when you're doing this too, and that's part of the purpose of these questions as well. So this is the skewness and the relationship of the mean to the median. So we asked you to explain what skewness was and whether it's positive or negative, and then to explain your answer about how the relationship of the mean to the median in a right skewed distribution. And again, for this group, okay, everyone pretty much gave a standard answer that we would expect to receive in a textbook. But one of the answers, so this is another thing that you can do, is you can take an answer that either is really good, it leads the class off in a direction that's different from what you expected, or a question that might start the class talking about other ideas. So this particular question, I've highlighted the word usually, even though that was not highlighted in the answer to the question. And so my question to my class might be, why would we say usually instead of always? Is there a case where the mean of the distribution of a right skewed distribution might not be to the right of the median? And what would that case be? Can you think of it? And of course, bimodal distributions, there's nothing in this question, by the way, that says this is a unimodal distribution. Sometimes people pick up on that, the really astute students pick up on it, and sometimes, and most of the time, though, you don't see it. And I didn't pick up on it, actually. Pavel was the one who wrote this question. I didn't pick up on it. I just gave the standard skewness thinking unimodal, that sort of thing. But if you can find answers that give that lead to discussion of the concepts, that's a good thing as well for the class and for you as a presenter or as the instructor in the class. I want to see at this point if Lynne might have anything to add to what I've been saying. I've been very kind of monopolizing the time here, so I don't know if she had anything to add at this point.
Took me a while to figure out how to unmute myself. Let's see. I think one of the things that has been most useful for me with these kinds of questions it helps you figure out what answers that students give often help you understand why they are misunderstanding an issue that you cannot imagine why they would misunderstand it to start with. So students, if you have them write their understanding or their explanation, it's very revealing. It turns out that in my teaching, maybe other people have discovered that in the past, but it turns out that in my teaching, I never had an opportunity, I never gave the students an opportunity to actually explain their answer in a way that I could comprehend why they were mistaking things. So this particular example, I don't know if Monnie, do you have the
No, I forgot
the
to.
other examples? So I had a question similar to this, where I asked students to describe the shape of what a histogram would look like if you asked students to say what they would like their weight to be. So I do a little questionnaire at the beginning of the semester where I ask a bunch of things, and one of the questions I ask is, what would you like for your weight to be? I also ask, what is your weight? And then anyway, so I asked them to speculate on what the shape of that distribution would be. And so they talk about skewness, and I had an example where I had a student say that they thought that it would be less skewed because everybody wants to weigh, all the girls want to not weigh very much. In other words, I can't remember the exact wording now, but it highlighted to me the fact that students mistake the direction that they're talking about for where most of the data are. And it turned out for a few semesters after that, I paid attention, and that was a very common way that people mistook what was meant by skewness. They mistook the direction of the tail for where the mass of the data are as a way of describing what skewness means. So that's just a little example of how something that I've been teaching for 30 years, I've never really understood that was why students misunderstand some things about shape, describing shapes of data. So my point here is that almost every after you get good at writing these questions, you can, it turns out that the same misunderstandings show up. So you actually, in later semesters, if you use the same questions, it turns out that you really don't have to, if you don't have time to read all the questions for your students previous to class, you can sort of rely on the misunderstandings that students in previous classes had because they are very consistent.
Thanks. And another thing to that too, and if you have I think Lynne's taught this method with a class of 100 students before, a lot of times it's only necessary to get about 20 or 30 of these questions before class to have a really good idea of what the students are thinking. So it's not that you have to go through all 100 or 300 or however many students you have in your class in order to understand how the students are thinking about a particular problem. Sometimes only 20 or 30 is enough. Of course, eventually you have to grade them all because it's part of their grade, but if you're running out of time, there are a few shortcuts for doing this. Okay, so just back to what JIT, or just-in-time teaching, is. Again, out of class, we have some sort of assignment out of class, whether that be reading or a video or maybe a newspaper article or a journal article. Many types of assignments. Sometimes I've asked students to do applets or to work through a particular Java applet that I find revealing and ask them to do certain things with that and then answer some what we call warm-up or pre-flight questions. We have discovered or at least I discovered the first semester that I did this, I called these quizzes. And the students hated that. That freaked them out that these were quizzes, and it made them very uptight about getting the right answer. So one of the things that's suggested from the physics literature, and by the way, physicists have been doing this for a very long time, I believe 1995, around that time was when one of the main works on this was published. They've never called these quizzes. They've always called them warm-up questions or pre-flight or pre-class or something like that that's much less intimidating than the word quiz. And so in class, you do show answers to students and discuss the answers. So just like I went up here, I showed this is an actual answer from one of you. I made the highlight myself, and of course I would point that out to my students. I highlighted this because I want to discuss the idea of why we say usually here instead of always. Or is it even correct to say usually? Should this person have said always? And get that to discuss in class. You would then correct them or discuss the concepts that the questions bring about, and then try to do some activity in class to reinforce the correct concepts. And that activity could actually be homework, some homework assignments from the book, but it would be much less, the students would be collaborating. I encourage collaboration in my class. I circulate around and try to help the students if they have a question. Because I remember when I was a college student, one of the things that happened to me a lot, and it usually happened in my math classes, was that I thought I understood the material, and then I'd go back to my dorm room or the library, wherever, and start to do the homework, and I'd realize that I didn't really understand it as well as I thought I had. But the professor wasn't there at that point to ask questions. And so we want to move the activities for which the professor is really needed and important into the classroom, and take the other activities that the professor, just the lecture things, the more passive activities, to outside of the classroom.
Let me say, this is Lynn, let me say one thing about that. As Monnie mentioned, I've taught this regularly with about 100 students in the class, and so when you have students doing activities in class, you may worry that there's not enough interaction. I did it with 2 TAs, so the 3 of us were able to, when you have students work in pairs, so that's 50 pairs, 3 people seem to be adequate for answering the number of questions, the kinds of questions that students might ask. If it was only you, I think it would be difficult, but I have done it with 1 when only 1 student was available, 1 TA was available, but 3 people, yourself and 2 TAs, would be ideal for 100 students.
Okay, thanks. So I want to try to do a small activity here, and we have a poll that's supposed to come up. And the idea is think, pair, share. Now, I don't know that our environment, this webinar environment, will allow you to do this, but the idea behind think, pair, share is that you would answer a question, and it can be a clicker question for those of you who are familiar with clickers, so you can throw it up on the screen and students can answer with a clicker, or you can do this by a show of hands, or you can do this we've done this in a very low-tech way where we just have give the students, each student gets a set of 4 index cards, and the index cards have written on them A, B, C, and D on them, and then they show their index card when we ask the question. And this professor takes a quick poll of what the students are saying, whether it's A, B, C, or D, and then we talk about that and redo the poll later. So here's the poll, and this was actually on the pre-class questions, and this question got a little bit of, I don't know, some people weren't very happy with this question, I guess, because it is tricky. But, and that brings up another point, is that one of the points of asking JIT questions is to try to elicit student misconceptions. Another point of asking JIT questions is to get them to discuss concepts. And this question is more about the latter. We want to discuss the concept of probability and what it means. And what happens when you might have a little bit of a change to what you might think would be the rules of probability. So I don't know if people are answering this question right now. So, and if
we have a few votes, so we'll give people just another maybe 20 seconds to choose an answer.
Okay. Sure.
Okay, I think we're going on. Let me see if I can figure out. Do you want me to see if I can show the results? I'm not sure how to do that.
That'd be great.
Let's see. That should be a thing. I don't know if Lori can tell me. This is my first poll. All right, let's see if I close it, maybe that will help. Oh, here we go. Now I can share it.
Okay.
There are the results.
Okay, so we have some instantaneous results here. It's funny that the first 25 was chosen, but not the last 25. So what we would do at this point in the classroom would be to ask. It's not really something that we can do in this setting, but we would ask students to answer the question and then turn to a neighbor. So we would pair them up and talk about your answer. So a lot of times you would turn to a neighbor, you hopefully would turn to a neighbor who answered differently than you did. And if that's the case, then you talk about your answers and you explain to your neighbor why I chose this number. So someone who chose 25% in that question might say, well, I chose this 25% because there are 4 answers, and we know that probability of getting something right if there are 4 answers is 1 out of 4. And then the person who answered 60% might say, have a different reason for that. And then you would talk about it, and then what the professor does after a few minutes, maybe 3 minutes or so, or usually they talk about what people say when they're doing Thinkpairshare is they talk about listening for the lull, where there's a decrease in the noise level of the classroom, or the point where conversations start to turn from probability to what you did this weekend or what movie you just saw or something like that. When you reach that point, you bring everyone back together and you re-poll them, ask the same question again. And then you would ask students, well, if you changed your mind, would you mind sharing with the class why you changed your mind? And we would talk about the concepts that are in this particular question. Now, this particular question, of course, when I remember the first time I looked at it, I was like, oh my gosh, the answer is 25%. But then I realized, whoa, there are 2 answers here that are 25%. How does that change things? When I was thinking through this question, I was thinking, okay, so we've got, really what we have is 3 answers. 25%, 50%, 60%, and 25%. There's really only 3 answers there. So that's really 1/3, but 1/3's not an option. But we know that 25% can't be right, so that means that there's really 2 answers here, 50% and 60%, and since there's only 2, that makes it 50%. Now, what am I doing here? I'm narrowing down the options, so that's one thing people are taught to do on multiple choice questions. I'm also using the laws of probability, or the rule that if you have a random choice, the correct choice or the probability that you choose a particular option is 1 out of the number of options that you have. And when you narrow down your options, at least I believe on this question, you really only have 2 options. So, but it goes into a lot of higher order thinking, and it has the students really think about what it's meant to be a random chance and how you can rule out some things when you're looking at a question. So I actually think this is a great question, and it always gets a lot of discussion when we ask it. We've used this multiple times now. I don't know if, Lynne, did you want to add anything to that? Lynne, are you there?
No, I lost my I lost my screen. No, I don't have anything. I actually have not used this one in class, so I don't have anything to add about that.
Okay, great. Thanks. So by the way, that Thinkpairshare is one thing you can do that's in class to get students talking with one another. There are many other ways to get students talking, asking them a homework question, asking them to work it. Some professors use the old notion of just going to the board, having students work problems on the board. All of those things are great. The point is to make the classroom more active. It may not be 100% activity, but just a little more activity to help the students sort of have an interest in the course, that they can't just show up to class and warm a seat. They actually have to be active when they're in this particular class and learning about the material.
I guess I do have one thing to say about the Thinkpairshare, although I didn't do this question. This was a piece of advice that I got from Pavel after I had been trying this in class for quite a long time. I noticed that students were even afraid to hold up. I used the very low-tech thing of I gave students 4 index cards of different colors, and I let them, with ABCD written on them, so I let them hold up the right color. It turned out that they were even seemed to be, in this class of 100, afraid to hold up their index card. And Pavel pointed out that in physics, they've long known when they're trying this, these kinds of activities in class, that you insist that students present their answer privately, because otherwise they tend to want to look and do what what most of the people in the class are doing. I did that, and it was like night and day, the participation and the speed with which they would answer. So the advice is, insist that they hold if they're using cards, they hold it where their neighbors cannot see it, or the only person that can see it is the instructor, because you don't want them to be so afraid that they're going to be getting the wrong answer that they're reluctant to participate.
Yeah, I absolutely agree with that. Thank you. All right, so this is the kind of week in the life / does it work part. And I want to give some background on the particular course where we've done these assessments. This is an introductory statistics course. It's part of our business degree. So students that are taking this course are typically interested in getting into the business school. And in order to do that, they have to have a certain GPA in these courses to get into the business school. So we have about 60% business majors, and then I've listed other majors that are also in the course. So it's a pretty diverse course in terms of majors. Usually 60 to 80, although Lynne's mentioned she's had over 100 in a course, and that's becoming more and more standard as statistics gets to be a more popular course to take at our university. So that's some background on the particular course we're talking about as far as the assessments go. Okay, for some reason I can't flip forward. There we go. We have, and what typically happens, so this is a Monday, Wednesday, Friday schedule. It would be slightly different for Tuesday, Thursday classes. We have both at SMU. So what you might do before your first class of the week is to assign the readings, or assign a video, or assign a web applet that students are supposed to do. Then record some sort of overview video summarizing the material for the week. And what's nice about the videos is that students can watch them over and over and over. So if they're having a hard time with something, let's say you're dealing with hypothesis testing or confidence intervals, those things which students typically take a while to absorb, those are great for that, because students can watch it over and over again. And the videos can be used over and over again once they're recorded. If you like what you had there, you can use that next semester. So just like with any other type of course, the first time you do this, it takes more time than subsequent iterations. So the first day of the week, you might go over extensions of the video material. So let's say you presented hypothesis testing again with one sample, and then you might want to go over, well, what happens if we have 2 samples perhaps, or what happens if we don't know the standard deviation of the population, what do we do then? And then you might do some lecture, some activity, discussion of research, how this might be used in a regular setting, what the p-value means when we're talking about a research article, those sorts of things. Now note that when we're saying flipping the classroom, in our case, we don't completely cut out lecture. It's about, I usually do 15 minutes or so of lecture every class period. And sometimes it's just for orientation, and sometimes it's to present something new. Sometimes it's just to regurgitate what they already should have learned. Again, because the more times they see the material, the better off they are when they're trying to master the material later on. Now, Wednesday is typically when the warm-up question is due, and that's when you need to review the responses and select the responses to display. So a lot of times we try to display the best responses. And also, and on occasion, if there is a misconception that is repeated, we try to display the responses that indicate misconceptions. But we don't want anyone to feel like they're being picked on. So we usually, if they're try to display 2 or 3 that show the same problem or the same difficulty in the student's thinking. That way the student whose responses are displayed knows that, oh, I'm not alone in this. And some iterations, or some people suggest using names of the students. When it's a really good answer, I do use a name to call out that student for a really good answer, but typically with the ones that I show as misconceptions, I don't use the student's name, again, not to make anyone feel bad. Sometimes students will actually volunteer their names. You show one that said, I really, this person or this particular answer shows this problem, like with skewness, for example. This particular person seems to understand that right skewness means that most of the answers, or most of the bulk of the data is on the left or on the right, and then they would say, then sometimes student will raise their hand and volunteer and say, well, hey, that was my answer, and this is what I was thinking. And when you get people like that, that makes the class pretty interesting as well. And obviously, you're going to prepare materials, and there's so much out there. So if your students are having problem with what shape a histogram is when you ask them that question, then there's so much out there to help students learn or understand that material better. It's often a question of just Googling something. We review responses on the obviously during class. We review the responses, talk about misconceptions and subtleties, and perform exercises to help the students understand what they missed. So that would be in class. Again, trying to make the classroom itself more active. Then in this particular course, we have a lab, a software lab on Fridays. If it's a Tuesday, Thursday course, the software lab is typically on Wednesday or Monday. So it depends on when you have a particular class. All right. Excuse me, sorry about that. So best practices, consistency is important, and also being explicit about the method, why you're doing what you're doing. And also explaining that there's a bunch of research to support this method and that it increases student learning. And that's the whole goal of this, to increase touch time with the material and to increase student learning. Also, you need to rehearse your activities prior to launch. I found myself in an embarrassing situation one time where I just pulled out an activity, ran with it to class, and then I realized that there was a mistake in the activity. So it's always a good idea to rehearse no matter how confident you are. And of course, adjusting with the class. That makes this particular course interesting, and it also makes it difficult because sometimes you don't get to go as fast as you would like to go or as you think you need to go in order to do the entire syllabus. Now, with an upper level course where your course it's not a prerequisite for another course, then that's okay. But if your course is a prerequisite for another course, then you might find yourself having to try to get the material in. It's a balancing act. Obviously, we want to have warm-up questions that require verbal responses, maybe some estimation, and some multiple choice questions. So a variety of types of answers that are required. And feedback is also important on the form. So questions like, how is the class going for you at this point, or what particular things do you not understand from the overview material? To ask students questions like that so that you can pick them up in lecture and make sure that at least you touch on what students say they're not understanding. These are some of the things that I thought that didn't go very well, and so that's why I have them as don'ts. Warm-ups due before every class period, too much. Too much for the students. Once a week is good. Too much for you as well. Covering new material outside of class, again, the students really complained about that on their evaluations, that they didn't want new material just outside of class and be expected to know it and then have to have a quiz on it, which, again, that was part of the problem. I call them quizzes, and to then do something totally different in class. So to have some sort of connection between your class time and your material that is on the videos or outside reading material. You don't want to completely replace your lectures with videos or reading, so you do want to have some lecture time in the class. Again, not being degrading toward wrong answers, not laughing at students, trying to show them that this is a very common misconception. That's also very important. And one of these last two, assume students retain all information, that was hard one on my part. I remember I had talked about the standard deviation early in the semester, one semester. I remember talking about the standard deviation, and then I had the students do an exercise on correlation, and one of the things that they had to do in order to calculate the correlation was to calculate standard deviation of the X and Y values. I had students asking me what the standard deviation was. And before you freak out and say, oh my gosh, you must not have taught that very well, maybe that was part of the problem. But the other part of the problem was that I was assuming that they are retaining all this information from what it might have been 2 weeks ago. We hadn't talked about the standard deviation in 2 weeks. So they needed a refresher. And it was a good thing, because now I can bring this in and say, oh, wait, we got to stop this. Let's talk about the standard deviation. Remember this? This was from a couple weeks ago. And this enters into the correlation in this particular way. So I was able to lead the students through, actually do a little test review right there, and then move into what I plan to do for the day. And of course, is concurring on all conventions, again, notation, those sorts of things. This is something that you need to be careful about when you're doing your videos and when you're instructing in class as well. Does it work? Well, of course, that's hard to define. We're going to assume that work means that it increases student learning. And how do we measure student learning? And again, another difficulty, we don't have randomized controlled trials typically in education. So what we typically wind up doing is a pre-test, post-test design, or some sort of interrupted time series design. So we used the latter, interrupted time series, where we compare learning before and after an implementation for the same teacher in this case. So how do we measure learning? Well, you need something to measure it by. And if you have a nationally normed test for your field, those are the best. Physics has nationally normed tests for various concepts in their field, so they can use these and compare against the norm for the nationwide on what their students are doing and how they're improving in their learning. You can also try giving the same final exam questions every semester, not the entire final, but just say 4 or 5 questions that you ask every semester to help you understand how students are improving or not improving as you teach your course. And you can use the same assessments that are used for SACS, or that SACS is our accreditation body. So sometimes we use those same assessments to assess student learning for each course. So what we did was actually use the ARTIST method, a free, nationally normed, brief test that measures concepts in statistics. So ARTIST, here's the plot that we have. It stands for Assessment Resource Tools for Improving Statistical Thinking. It's a nationally normed series of assessments that's freely available online, and there's a thing called the post-test, a comprehensive post-test, and a comprehensive pre-test. So what you see here on the vertical axis is the ARTIST test score for the pre-test in red, the post-test in green, and then the difference is down there at the bottom in that brown color. And you see the arrow where the JIT was implemented. So the horizontal axis is the various semesters. So we have spring 2011, fall 2011, spring 12, fall 2012, etc. And JIT was implemented in the fall of 2013, and you can see that there's a slight uptick in the scores for the students, and also an uptick in the difference. So that we are encouraged by these results to help us see that it looks like students seem to be learning better with this particular method. I don't know if Lynn do you want to add anything at this point?
No, I don't think
okay.
I covered it.
Okay, thanks. So if you're feeling overwhelmed, then again, you don't have to do this all the way in. You can just do a couple of things. One of them is to record some FAQs, for example, or maybe some videos. If you're using software, how do I import my data into SAS? Or how do I import my data into SPSS? Or if you're asking them to do a paper, how do I reference a paper? And these can be done throughout the semester, and those might be things that you just want to put online, so that if you get questions that you get asked all the time, every semester, you can put them online in a video form, so that students can have them to refer to. Or I think how Lynne started out was just recording a homework assignment instead of giving a text solution. So this is practice with video recording equipment on your computer. It's a screen capture equipment on your computer, actually. Or you can record, I mean, when I say record, I mean video record answers to an exam review. So instead of just posting a text solution set, you can actually post them in video format, or post a couple in video format. And here's just some ideas for software. What I did was I actually just Googled screen capture software for free, and this is what I got. This just list. This is both Mac and PC mixed in here, and then there's this link to top 10 reviews of best video capture software. That particular link goes to commercially available software, and the cost is anywhere from $40 to $80. It's typically pretty inexpensive to purchase this software, but there's also a lot of good stuff available for free, or a lot of good stuff that's available free for 30 days. So you can at least try it out before you decide to buy it. Here's some references, and I can just take some questions at this time. Thank you very much.
All right, thank you, Monnie and Lynne. We appreciate your presentation today. I did get a notice from Pavel. He said he wanted to comment a little bit on the Thinkpairshare, so I'm going to try to unmute him and let him do that.
Okay,
Pavel, there you go. Yep, go ahead.
Yes, so I just wanted to quickly comment on some of the participants' feedback on this Thinkpairshare question. And indeed, it is an unusual question, and so you have to think before you give it to the class. And certainly, it's probably more advanced than the typical warm-up question for an undergraduate course. But on the other hand, I believe it can work well, for example, at the graduate level. And something that I wish to mention is that this GITT technique does not have to apply only in the undergraduate courses or in large courses. We also successfully use it in small classes, and clearly you can come up with more complex examples which will literally require more proficiency to answer them. Now this question, just to quickly describe where it comes from, it is posted online, and it generated a very long thread of discussion, and so and that's actually one of the nice features of these warm-up questions, that the best question does not have to have one answer. It may have several answers. It may even be wrong, or it may be controversial. But the goal of this question is to generate the discussion. And so when you collect the answers, you realize that you may have several valid ways of thinking about this question. And so you also need to apply certain previous knowledge or certain skills that you gained from the previous courses, and that's what you see in your answers to these questions. So that in fact, if you look, I think if you look on the internet, you realize that any of these four question answers, A, B, C, and D, can be correct depending on your logic, as well as the answers of 0% or 100%. And so you can, well, as somebody again correctly pointed out in the answers, well, you can trace it to the linguistic paradox, the famous Barber paradox by Russell. Well, it's quite deep, and you can go really deeply to think about the concepts. But also, when you answer this question, perhaps you get a little bit of feeling what your students will feel when they answer these questions, because they are quite confusing, and they really challenge them and try to, and they sort of apply the knowledge that you teach in your course in a more realistic situation when often you don't have one answer, but you may have the best answer, the better answer, and several wrong answers. And these are the kind of questions that work quite well in the GITT method.
Pavel, could you comment on I know physics has a website that has a sort of a collection of these kinds of questions. Can you talk a little bit about where that came from and what it is?
Right. So, historically, the GITT method was proposed at about the same time as the peer instruction, and it was realized that students don't spend enough time to prepare outside of the class, and in the class the time was used inefficiently when instructors would go into long lectures, and students will just passively listen to these instructors. So then GITT was proposed as a way to free some time for in-class activities. And as you see again, so it's one of the versions of the flipped classroom that is easier to implement. GITT has a website, and I can post a link to this website, which collects problems and questions, which come in several different types. But a good combination is when you include a simple multiple choice question, a free-form conceptual answer question, and some sort of estimation problem. But of course, you can also use other combinations. So the website that I will send the link, but it started as a collection of physics problems for the warm-ups, but now it has grown to include problems from other domains, and certainly it will be good to have a similar repository of the problems for the statistics courses.
Okay, great. Do we have any other questions from participants?
I have a question from Rebecca Pierce. She says, have you written an article in which you present the results of your study?
Yes, that article appeared in the Journal of Statistics Education, I believe, in April or May of 2016. Lynne, Pavel, and I are all three authors on that paper, and I believe it has the same title as this webinar. So it should be easy to look up. It's against the Journal of Statistics Education.
Okay, thank you. Does anyone else have any questions? Just go ahead and type them in the question box here, and I'll get those answered, or I'll ask them.
I guess while people are typing questions, let me mention this one, this reference that I have highlighted in red down there at the bottom. That is a book, and I really like this particular book because it has not only just statistics or physics in there, but there's examples of how people use just-in-time teaching in archaeology, geology, English, history, really across the disciplines, and you can get a lot of good ideas from what other people have done. Again, that particular one is in red down there at the bottom. It's a book that has a lot of different articles on how to implement or how to or examples of how this is used in various places.
Okay, well, that was the other question. Why was that reference in red? So
that's why. There's a reason.
Okay, there we go. I'm glad you answered that. That was very prescient of you. And then Pavel has just posted in the questions box, for those of you who are interested, the link to those resources for the just-in-time teaching. We'd like to thank you for presenting to us today, all three of you, Dr. McGee, Dr. Podolsky, and Dr. Stokes. And we encourage you to keep your eyes on the CAUSE webinar website. We have some things in the pike coming up for February and the months ahead, so please keep your eyes on that and come back for our next teaching and learning webinar. Thanks, everyone.
Right. Thank you.